So on this question, they say that they want you to, okay, let's look at the table that we are given. We are given a table below. The boiling points of 4 hydrogen halides are given. And then we have A, B, C, and D. Okay, so we're going to look at what we are given. We have the boiling points for each hydrogen halide. Now, the first question, they want you to define boiling point. I'm not sure. I think we did define this one on our last lesson. Do you still remember the definition of boiling point?
The temperature at which a substance changes from liquid to gas.
From liquid to gas. Okay, so now it is the temperature when liquid changes into gas through the liquid, or you can just get the definition from your textbook. Then now on 3.2, they're asking you, what is the relationship between the strength of the intermolecular forces and boiling point? For 1 marks, this tells us that this should be easy. Listen, when they ask you about the relationship, strength, remember, the stronger the intermolecular force, the higher the boiling point. You understand? That's the relationship. Are you with me?
Yes.
So why is this case that if we have a stronger intermolecular force, the higher the boiling point? Do you know why? What is the reason for that?
Energy to overcome.
More energy is needed to separate molecules. You understand?
Yes. That's
okay. The stronger the intermolecular force, this gives us the higher the boiling point. So on this table, the one that has the stronger molecule is the one that has the higher boiling point. And the reason for this is that more energy is needed to separate molecules. Okay, 3.3, which of the hydrogen halide, A, B, C, or D, in the table above has the 3.3.1 has the highest vapor pressure? Refer to the boiling point in the table above and give a reason. What do you think will be the answer for this one?
I'm not sure. I've never seen a question like this.
Okay, remember that when you say this thing, you need to look at the one with the lowest boiling point. The lower the boiling point, the higher the vapor pressure. So if you are looking for the one that has the higher vapor pressure, you need to look for the one that has the lowest boiling point, and will definitely give that as a reason. So the correct answer for this one, we're gonna look the one that is lowest. Tell me which one is the lowest boiling point.
Hydrogen bromide.
Hydrogen bromide. Why is hydrogen bromide? Remember, I still have minus 85.
Oh no, minus 85. Yeah, hydrogen chloride.
Yes. So it won't be hydrogen bromide, but it's going to be HCl. So the correct answer for this one is going to be HCl, which is.
So what is vapor pressure?
I'm listening.
What is vapor pressure?
Vapor pressure. You know when? Can you give me a second? Okay. So now, when we say, for the best way that you can understand vapor pressure, vapor pressure, let's say the pressure that we exert by, do you know what is thermodynamic equilibrium?
No.
When you put something in a closed system. Do you know what is a closed system? So
No.
you don't know what is a closed system.
No.
A vapor pressure, it's a pressure that we exert by vapor when we reach equilibrium. You understand? It can be in solid or in liquid. But whatever that we are doing, it should be inside a closed system.
Okay.
Right. So now the vapor pressure, it will help you to indicate the liquid's tendency to evaporate. You understand?
Yes.
Okay. So now we are saying that the correct answer for this one, it's HCl, which is compound B, and the resin is the one that has the lowest boiling point. So the one that has the lowest boiling point is the one that will have the higher vapor pressure. Can we move to the next question?
Yes.
Okay. So now they are asking us the strongest intermolecular force. Remember on 3.2 we
Hydrogen.
said, yes, on 3.2 we said the stronger the intermolecular force, the higher the boiling point. You just have to look at the one that has the highest boiling point, which is hydrogen. And what will be the reason? Because this one has the highest boiling point. Okay, let's work on the next one. They want us to draw a line graph to represent the boiling points of the hydrogen halides for just 6 marks. Can you believe? For 6 marks, we need to draw the graph. Okay, so when you draw the graph, I know that sometimes we say the graph is easy, but make sure that one thing first, because this is 6 marks, né? Make sure that you give your graph a heading. There's a mark for that. So what will be the heading of this graph? If they want us to draw a line graph to represent the boiling point of the hydrogen halide, what will be the heading?
Graph showing the boiling points of hydrogen halides.
Exactly, thank you. You just take it from that statement. So this will be on top, you're gonna say boiling point of hydrogen, or you can say different types of hydrogen halide. Different types of hydrogen halides. Okay, now you need to understand which one will be the independent, which one will be the dependent. Okay, so on this part here, I'm just gonna put my hydrogen halide on my X. So this will be my hydrogen halides, and then this side we're gonna put our boiling points. Then let's quickly look at these boiling points, how they move. 19.4, maybe 20, and minus 85, maybe 80 or 90, 67, maybe 70. I'm trying to get a scale, the right scale. And I think the right scale will be if we say 20, 40, 60, 80, and 90, but we have negatives. So this is going to be very tricky. I need to create the horizontal, or let's say the reference point. Somewhere here, I need to create the reference point, which is 0.0. You understand? Then going up, this will be 0, 20, 40, 60. Then this will be negative 20. We go down negative 40, negative 60, negative 8, and so on. Right. So when I do the graph, let me first start with the HF. if I say this is my HF, I need to put the HF at that 19.4, which is close to 20. So I'm just gonna put it somewhere up here. Oh, it should be below, ne? Are you still with me? Let's put it somewhere here. And then let's plot for the next one, which is minus 85. I think it should be, when I put it like this, I'll have to fix this part, maybe bring it more down like this. So that I can get that minus 85. Okay. So minus 85, this is HF. The next one that we have on the list is HCl. So HCl should be somewhere down here before minus 85. And then as we keep moving, the next one, minus 67 should be after 60. Oh, before 60. It should be somewhere down here. I think you understand what is going on, right? HBr. Are you good on your side? Are you still with me?
Yes.
Okay. So, and then we're gonna have the last one, which is HI minus 35.5. It should be somewhere before 40. But tell me, is this correct if we name our HF on that part? Is it correct? I'm just gonna plot my graph like this, then it moved to that, and then it's gonna move to that. I think this is 0. This is where we should name our halides. This should be HF, and then this should be HCl, and this should be
Why don't we name them there?
When we put it down there, it doesn't make any sense, because remember, we still have what? We still have 90, minus 90 going down. So I think to be on the safe side, just put them on that part. You understand?
Okay.
Right. So I think there's a mark for a scale. So they'll give you maybe the part where you need to draw net, and then you're gonna get a mark for 4 points correctly, you get 2 marks. If the points are correctly, then you'll definitely get 2 marks. And then if the line graph, the shape of the graph is correct, you'll get another mark. There's a mark for labeling the hydrogen halide and also the boiling point. And there's another mark for the heading, which makes 6 marks. You understand?
Yes.
Okay. So I'll definitely show you the correct graph. Let me just okay, I'll show you the graph, don't worry. Okay, I'll find the memo for this. Let's look at how the graph will look like. Okay, so now they say compare compounds A and B, refer to the type and the strength of the intermolecular force and energy needed to explain the difference in boiling points between hydrogen halide. Let's make sure that we understand what is the question saying. Okay, they say that compare A and B. Let's first write down the compounds A and B. I'm just gonna put my compound down here. A, that's HF, and B, that's HCl. Okay, HF, and then B, that's HCl. So they want us to compare these two compounds, okay? And then refer to the type and the strength of the intermolecular forces and energy that is needed so that we can explain the difference in boiling points. Okay, So HF, it has what? HF, let's first talk about the type of the intermolecular force. Né? Can we start with the type of the intermolecular force first?
Okay.
What is the type of intermolecular force for HF?
Hydrogen bonding.
Exactly. So this will be the hydrogen. This will be the hydrogen bonding. Okay. So, and then we can see that HCl, this one will be the dipole forces. So that is the type of the force. Let's talk about the strength. So we know that for hydrogen bonding, the hydrogen bonding are very strong. So this one, they are very strong, and then this one, they are weaker. Okay. So now, the ones that are strong, we're gonna talk about the energy needed. Obviously, the strong one needs more energy needed to break the forces. More energy needed to break forces. And then what about this one? This one, less energy needed. I think I did give you answer. The answer on this one. So now HF, we know that this HF has what? The HF has a higher boiling point. Okay, let me just put it like this. Don't worry, this is the last question, then we'll move to calculations. So HF, we've seen that this one is a higher boiling point. So this one will have a lower boiling point. So now when you write your final answer, you're going to say HF has the hydrogen bonding while HCl has dipole forces. Then
But how come HCl isn't a hydrogen bond?
how come
HCl isn't a hydrogen bond.
HCl is a hydrogen bond?
I'm asking why isn't it?
I'm not sure if I understand your question.
Why isn't HCl a hydrogen bond?
Why is it a hydrogen bond?
Why isn't it a
Or
hydrogen?
why is it not a hydrogen bond?
Yes.
Oh, okay. So listen, if you look at the HCl, let me quickly explain this one. So you see the HCl does not form a strong bond, and I'll definitely explain that part, because remember the hydrogen bond, if I have HCl, oh, that issue again. So if I have the hydrogen bond, because of the chlorine, you know this chlorine, the atom is too large. You understand? So since the atom is too large, this the size of the chlorine, it dispenses its electronegativity over what? A wide area, and it fails to create the concentrated charge density required for an effective hydrogen bond. I'm not sure if this answers your question.
It does, thank you.
Okay, you see we have that writing issue again today. Oh, okay. So let's look at this question 5. Oh, I'm sorry. Let's go back and make sure that we explain this part now. We said that to the final answer, you're gonna tell the marker that HF has hydrogen bonding while HCl has a dipole forces, and hydrogen bonding are the ones that are stronger than dipole forces. Therefore, more energy is required to overcome the intermolecular forces in HF. This results HF having a higher boiling point than HCl. Are you happy with that?
Yes.
Okay, let's go to stoichiometry calculations. We only have close to 15 minutes. Hopefully we can finish this question in 15 minutes. I hope so. Question 5. I don't know how to pronounce this word. So they said that what is that?
Effervescence.
What?
Effervescence.
Okay. Is it for the first time you see the word, or maybe you guys did this at school?
No, I've heard it before. It's like something like it gives off gas,
Oh,
or it's
okay.
like vivacious, you know.
And
I've heard it. I've never like seen it.
okay. So now they say that is seen when diluted hydrochloric acid it reacts with sodium carbonate, and we can see the balance equation is given. And the first question they want us to write the formula of the substance that cause whatever that is seen. I just don't understand. Let me just quickly make sure that I understand what is this. It's for the first time, I don't want to lie.
It's like bubbling, releasing gas.
Oh, bubbling gas. Nice. So if they say if this thing is
Or fizzing, yeah, fizzing.
I hate this thing, you know. I don't wanna lie. So if this is bubbling gas, then we already know what is the answer, right? Oh shucks, I can't write. What should I do?
Should we switch to Google Meet?
I'll try. Let me try again. Without wasting time, let's just quickly switch, ne?
Okay, please send me a link.
Okay. When you say bubbling gas, everything now makes sense. So now, if this one, the gas causing this, remember, you're saying this is bubbling gas. So the correct answer will be carbon, CO2, ne? So this is and the question is asking, write the formula of the substance that causes the bubbling gas. We know that it's gonna be CO2. That's the answer. Are you happy with that?
Yes.
Okay, in a reaction, we have 10.6 grams of sodium carbonate. It reacts, let me underline the word, completely with excess hydrochloric acid. So define 1 mole of a substance. 1 mole of a substance, this is the amount, of a substance that containing what? It contains 6.02 times 10 to the power 23 particles. Okay, I think you understand this one, no? The definition.
Yes.
Right. So some they say the amount of substance is having the same number of particles as there are atoms in, let's say, 12 grams carbon, something like that. But it's fine. You can just take the definition from your exam guideline. So now, which substance is the limiting reagent? Do you know what is the limiting reagent?
The what?
Do you know what is a limiting reagent?
No.
You see, when I say limiting, this is the substance that will run out first. The substance that runs out first. So that the one that will run out first, it will be the limiting reagent. And if you look at this, give a reason for your answer. Look at the statement. They said that in a reaction, 10 grams of sodium carbonate, okay, sodium carbonate. So the sodium carbonate, the formula for that sodium carbonate is Na2CO3. Oh, shucks. So this formula is for that sodium carbonate. They say it reacts completely with excess. You see the with excess, it means the one that is more. So hydrochloric is more, and then sodium carbonate is the one that will run out first. You understand?
Yes.
You still with me? So the correct answer, it will be sodium carbonate. It will be the limiting reagent. So the Na2SO3 is the limiting reagent, and the reason is that HCl is given as it's in what? It's in excess. All happy, right?
Yes.
For 5 marks, calculate the mass of CO2 produced during this reaction. For 5 marks. I need to take this one step by step. I know that we only left with 5 minutes, but I definitely have to take it step by step. You understand? So that if I do this step by step, then it's very important that you understand all the calculations that I will do for us to find this question.
Okay.
Okay, so first thing first, we need to, if you look at this, they want the mass of CO producing this reaction, and I'm just gonna work this thing out this side. Okay, so the formula for mass, if I need the formula for mass, remember the formula for mass is the number of moles multiplied by the molar mass. We are looking for the mass of CO2. Okay, so this tells you that first thing first, I can calculate the molar mass of what? CO2 using the periodic table. You still with me?
Yes, it's 12 plus 16 times 2.
And what is that equals to? Carbon is 12, right?
It's 44.
Okay, so it's 12 plus into 16 times 2. This gives us the molar mass of 44 grams per mole. So this is your molar mass. Already on the formula you have the molar mass. What's next? To find the number of moles.
You times by Avogadro's number.
You're going to?
Times by Avogadro's number.
To find the number of moles. Do you have the number of particles? Are we given the number of particles?
No.
So the Avogadro's number won't work because that formula, we can definitely use it if we have the number. Let me just quickly confirm before I say no to your formula. So the Na will need the number of particles. So we don't have that. So now it's fine. I'll stick to this formula. Let me go back to the question. The question wants you to find the number of moles of what? The mass for CO2 produced during this reaction. But remember, you have the mass of sodium carbonate. We can use this mass to calculate the number of moles of this sodium and then use the mole ratio. You understand? We have M, the small m, and then we can use the formula N is equal to small m over big M. We have this, we can calculate this. Once we have the number of moles for sodium carbonate, we use the mole ratio. Do you understand? And if you look at this is just 1 and this is also 1. So the mole ratio is 1:1. Whatever answer that you get, so the number of moles for sodium carbonate is the same as the number of moles for carbon dioxide. So when we have that number of moles, we'll come back and substitute it here. Are you happy with that? Are you still with me?
Sorry, sir. Please repeat.
Okay. If you look at this question, this is the formula that we're going to use to find the mass of CO2. So on the mass, we already have the molar mass. The next step is to find the number of moles for CO2. But we don't have enough information on CO2. Okay. But when you look at the statement we are given the mass of what? The mass of sodium carbonate. You understand? We can use this mass to calculate the number of moles for what? For sodium carbonate, then we use the mole ratio to calculate the number of moles for that carbon dioxide. Should I take this step by step?
Yes, please.
Okay. First step, let's calculate moles of that sodium carbonate. So if you still remember the formula, it's N is equal to small m over big M. I need to find the molar mass of that Na2CO3. So what will be for N? Sodium is 23, right?
Yes.
But
23.
there are 2 of them, and then carbon it's 16.
It's
but
just 16
carbon is 12.
is 12, and then 16 plus 16 times 3.
Yes. Punch that on the calculator, tell me what you get. 16 times 3. What is the molar mass of sodium carbonate?
106.
Okay. So this is 106 grams per mole. So this is the molar mass, and then the mass, small m, was given as 10.6 grams. Okay, so this is what we have. We can definitely sub in everything to find the number of moles of that Na2CO3. So it will be the small mass, which is 10.6, over the big M, which is the molar mass. Then 106, 10.6 divided by 106. Therefore, what is the number of moles equals to? What is 10.6 divided by 106?
1/10.
And in decimal form, 0.1.
0.1, yeah.
So this is the number of moles for what? Sodium carbonate. Okay, so now that you have the number of moles for sodium carbonate, we're going to use the mole ratio, then we're going to convert what? Then that's when you can convert to mass. So first thing first, you use mole ratio So it's gonna be Na2 CO3 is to CO2. So this is 1:1. Therefore, they have equal number of moles. So the number of moles for CO2 is just that 0.1 mole. You understand how I got this?
No.
Okay, look at this. The mole ratio is 1:1, right?
Okay.
How did we get 1:1? The 1 is this 1. There's no number in front of sodium, so we know that it's just 1. So the coefficient or the number in front is just 1. There's 1 sodium. Also, this side we only need 1 carbon. So since it's 1:1, therefore they'll have equal number of moles. So we know that the number of moles for this one is 0.1, which makes this one also to be 0.1. Do you understand?
Yes.
So now you're going to take this and substitute it back on that equation. We take this number of moles, we substitute it back on this equation. So the number of moles, the mass, let me write it down here. Therefore, the mass is the number of moles times the molar mass. The number of moles is 0.1 multiplied by the molar mass of carbon, which was 44. What was that? I think was 44, right? We calculated this to be 44. We are looking for the mass of CO2. Then you're gonna take the 0.1 multiplied by 44. What do you get?
Um, 4,4.
4,4 grams. And that's your answer.
Okay.
So there's 4,4 grams of CO2.
Okay.
Next question. This is the last one, 5 marks, ne?
Okay, so can we please do maths tomorrow? I'm not feeling too well.
Oh, okay, it's fine. We can end here. Then should we do this question? Then we'll continue with maths tomorrow, ne?
Yes, please.
Okay, let's
We'll also do chemistry tomorrow for an hour.
Okay, let's conclude this 5.2.4, ne?
Okay.
They want you to calculate the mass of sodium chloride. I want to teach you something here, ne? These are not the type of questions where you should lose marks, ne? You see, when you see this formula here, what can I say? When they want you to...
Are they gonna give us the formulas like N equals V over Vm? Like they give us those? Okay.
Yes, they'll give you the formula. You see, when you see the weight STP, ne? Just know that the formula that you should use, it must have Vm. You go to formula sheet, they want you to calculate the mass M of sodium chloride. Okay, so the mass of sodium chloride, that's NaCl, produced if you are given the volume of carbon is produced at STP, the volume of carbon. Look at this. You'll go back to your formula sheet, go down to your formula sheet, and then you click this formula that has Vm. Because of STP, this is the formula that you need to use. You write this formula down. I'll definitely write my formula down. So this is 5.2.4. So on this formula, we said the number of moles is V over Vm. And now we are looking for the mass of sodium chloride from the CO2 volume. Okay, so now I need to find the number of moles, because remember, this is exactly what we were doing last time. We said the mass is the number of moles times the molar mass. But we are coming back to this question. Let me first find the number of moles using this formula. The number of moles is the volume that was given, which, if we go back to the question paper, the volume is given as, what is this? 4.87. This is my volume, 4.87. So I'll just take the 4.87, substitute it on that formula, and then divide by Vm. The Vm is on your table, on your constant table. This is the constant table. So this is your Vm, which will be 22.4. I hope this makes sense. Let me quickly go back and substitute that. $22.4. You punch this on the calculator. What is the number of moles of CO2? What is the number of moles of CO2? What do you get?
Sorry, sir.
Can you punch this on the calculator? The 4.87 divided by 22.4. What is your answer?
Come in. Sorry, sir. Give me 2 seconds. Zero comma 2 what? 0.22.
0.217 on my side if I just leave it like that, né?
Yeah.
Okay. So you see this number of moles. This is for carbon. And we're going to use the mole ratio to find the number of moles for NCl. You go back to your original equation. You look at the original equation. So what will be the mole ratio for sodium chloride and carbon dioxide? Look at this. This is 2. This is 1. So the mole ratio is 2:1. You understand that part?
Yes.
Wait. I'm doing this wrong. Eh? They said sodium chloride, NaCl. This is 2 and this is 1. So the ratio is 2:1. Then I'll definitely write it here. The mole ratio for CO2 is 2 NaCl. So the ratio is, for this one it's 1, for this one is 2. Okay, so if the number of moles for this one is 0.217 and the mole ratio is 1:2, to find the number of moles of NaCl, you take that 0.217, you're gonna multiply that by 2, because the mole ratio tells you that this is 2 times that. You understand? Are you still with me?
Yes.
Then you're gonna multiply the 2 to find the number of moles of that sodium chloride, which gives us 0.434 mole. So I'm just gonna highlight this because we definitely need this to move to the next step. So now that you have the number of moles for sodium, you can come back to this formula and do the substitution. So the mass, you take that number of moles, which was 0.434, you need to multiply by the molar mass of sodium chloride. We need to find the molar mass of that sodium chloride. The molar mass of NaCl is equals to, we said Na is 23. I'm gonna add Cl, which is 35.5. We add the 2, we get 58.5. 5 grams per mole. So we're going to say where there's molar mass, we sub in 58 grams per mole. So this will be 58.5. Therefore, you multiply these two numbers, this will give you the mass. Let me also put it on my calculator on my side. 0.434 times 58.5. This is 25.39. So the mass of sodium chloride is that 25.39 grams. I'm not sure if you are following the steps, because it's very important to follow the steps, understand where we start, what you need to calculate, how to use the mole ratio. Very important. You understand?
Yes, sir.
Right. But you know, one thing, remember that all these sessions are recorded. If you want to go back to the lesson for reinforcement, you are more than welcome to request the link for the lesson, okay?
Can you please send me the link for this lesson?
This one?
Yes.
Okay, I'll definitely send you the link.
Thank you.
Okay, thanks. I'll see you tomorrow.
Cool. Thank you. Bye.
Please get well soon.
Thank you.